Welcome back to Forward CloudSec. Again, your friendly reminder that there's a feedback form pinned to the Forward Cloud Slack channel in the Cloud Security Forum Slack. Your feedback is very critical to us to ensure that we're able to make this good for you, the community, because we're really here for you. Before we start, I'd like to thank all of our sponsors, especially our gold sponsor, Lightspin. Lightspin prioritizes exploitable cloud risk via graph technology that connects the dots of OpenCVEs, malware, risky roles, and then serves DevOps simple remediation via IAC. For those in the room, please silence your cell phones and use the mic to ask questions. Raise your hand, and I will bring the mic to you for the ability of our online listeners to hear your questions. For remote attendees, we'll be looking for questions on Slack. That said, please welcome Nir Ohfeld and Rotem Lipowitch.
Thank you. So, thank you for joining our talk, Secret Agents, Demystifying, and Pwning Cloud Middleware. My name is Nir Ohfeld, and here with me on stage is Rotem Lipowitch. We are both security researchers, a part of Wiz Research team, a group of experienced researchers focusing on finding new attack vectors and threats in the cloud. And now you might be familiar with some of our previous work, findings like ChaosDB and Extra Replica, both cross-tenant database vulnerabilities affecting Azure, and, oh my God, a cloud middleware vulnerability that we are going to talk about later on in today's session. But before we can dive into the vulnerabilities, we first need to talk about something that I assume most of you are already quite familiar with, the cloud. So you probably all know the cloud, love the cloud. Otherwise, why are you here? So let's talk about something a bit more specific, virtual machines in the cloud. Virtual machines are one of the most basic building blocks in the cloud. And almost every cloud provider has some kind of offering of virtual machines. And from our experience, almost every cloud environment has at least one instance of a virtual machine. And cloud service providers offer you all the things that you'll expect from a virtual machine. You can choose the hardware, the operating system. You can take snapshots, configure networking, start, restart, shut down, and more. But all of these things are things that you expect to get on every virtual machine. And they're also available on virtual machines on on-premise environments. And cloud service providers offer much more advanced capabilities. Things like CI/CD, log collection, software update, configuration management, and much, much more. And looking at this list, we couldn't help but wonder, how cloud service providers are able to provide us with all of these wonderful functionalities. And after doing some research, we came to the conclusion that all cloud service providers are using something called cloud middleware, when in reality, it is just a fancy name for agents. Cloud middleware agents are usually installed by the user, but sometimes they are pre-installed in the operating system image, or they are implicitly installed when the customer enables a certain feature on the portal. Now, when it comes to cloud middleware agents, we should ask ourselves the very same hard questions we ask ourselves on every agent. Things like, which privileges do these agents have? How do these agents get security updates? Do they expose a potential attack surface? And most importantly, who is responsible for maintaining these agents? Is the cloud vendor responsible for the maintenance of these agents? Am I responsible for the maintenance of these agents in my environment? To address these very questions, cloud providers came up with the shared responsibility model. The shared responsibility model dictates the various responsibilities regarding various security issues. Things like physical security or the security of managed services are all under the vendor responsibility. But things like configuration and the software running on top of the virtual machine all should be handled by the customer. This definition puts cloud middleware in quite a difficult spot. On the one hand, it is software that runs on the customer's virtual machine. meaning that the customer should maintain it. But how is the customer supposed to maintain an agent he doesn't even know is there? To illustrate this very issue, I'm going to walk you through one of my personal favorite cloud middleware software, the Azure OMI agent. The Azure OMI agent is one of the most prevalent cloud middleware software found in Azure. It is short for Open Management Infrastructure, and it is an open source project by Microsoft in a collaboration with the Open Group. Essentially, it is a Windows management infrastructure, also known as WMI for Unix and Linux systems. And like WMI, you can use OMI to gather statistics and sync configurations from across your environment. And due to the ease of use and abstraction that OMI provides, it is used extensively by Azure in many Azure services, in services like Azure Automation, Azure Insights, OMS, and many, many more. But I'm a security researcher, so whenever I look at a piece of software, I immediately look at it from a security perspective. And from a security perspective, OMI runs at high privileges, and in some configurations, it even supports external HTTP requests, essentially opening a remote attack surface. But on the other end, it is open source, meaning that security researchers like myself can audit its code and contribute for its security posture. So for me, it made a very good candidate for my first cloud middleware research. And after a few good days of research, I came up with some interesting findings, including an unauthenticated RCE as root and 3 other privilege escalation vulnerabilities. And one of the more interesting things about the unauthenticated RCE is that it is dead simple. It is so simple that its exploit can be illustrated with a simple animation. So let's go through the RCE vulnerability in animation form. As I just mentioned, OMI supports remote management via HTTP, and via this remote management, OMI supports command execution. Now, this functionality obviously requires some sort of authentication. Otherwise, anyone on the internet can execute code on your machine. And the authentication is passed in the HTTP authorization header. So let's look at it right now. This is the example usage of a normal OMI usage. We are executing the ID command to show that in this example, where we are using the privileges of the authentication credentials of the victim, we are running at the privileges of the victim. Now, let's try to challenge the server and send invalid credentials, credentials that won't work. We'll do just that, and as you would expect, sending the exact same request with the ID command doesn't work, and it returns an HTTP 401 unauthorized response, which indicates that because we supplied invalid credentials, we are unauthorized to use the service. But now, let's try to do something funny. We'll issue the exact same HTTP request, but this time we'll supply no credentials. We'll simply omit the HTTP authorization header. What do you expect to happen? I personally expected to get the same response I got when I sent invalid credentials, a 401 unauthorized response. But let's see. We're sending the exact same HTTP response, executing the ID command, but this time, no authorization header. And the command executes. And not only does the command execute, it executes at the highest privileges possible, root privileges. Oh my God. So finding this vulnerability on June 2021, we sent it to Microsoft, and they assured us that all of the vulnerabilities are going to be addressed on September's Patch Tuesday. September's Patch Tuesday came along, and Microsoft did release the advisory regarding all of the 4 patches for the reported vulnerabilities. But looking at the advisory, we at Wiz, we were quite shocked. In the initial advisory, customers were required to manually update the agents. And the advisory did not even state that the vulnerability affects Azure workloads. And as OMI is a secretly installed agent, most customers are not familiar with OMI. And even customers that are somehow familiar with OMI and want to apply the provided mitigations soon discover that the provided mitigation guidelines simply do not work. And on top of that, for the 48 hours after the initial publication of the vulnerability, Azure was still serving a vulnerable agent when you enabled the features that install the OMI agent. Combining all of these factors basically left Azure customers vulnerable and essentially helpless. Following that, we arranged an emergency meeting with the Microsoft team, informing them that the provided mitigation guidelines are not working and that Azure is still serving a vulnerable agent. And having this kind of easily exploitable vulnerability in such a prevalent agent that is simply not getting patched, it came to no surprise that malicious actors were starting to take advantage of these vulnerabilities and starting to exploit the vulnerabilities in the wild. And Microsoft, following this evidence, in a pretty impressive operation, almost immediately auto-updated all of the Azure installations of OMI. And on top of that, Microsoft even provided more details regarding the mitigation guidelines that helped all of the OMI users outside of Azure. So in this case, Microsoft really stepped up their game and ended the entire Oh My God story with a very positive note. After the Oh My God incident, we were introduced to the cloud middleware issue, and recently we conducted a research regarding the patching rate of the various cloud middleware software across cloud providers. And I now want to invite Rotem Lipowitch to stage to walk you through some very surprising statistics.
Thank you, Nir. So, as Nir said, after the Oh My God events, we decided to conduct a research regarding the patching statistics of different cloud middleware agents, and we'll start with OMI. As you can see, the OMI version distribution is pretty great. Why is it great? 87% of the OMI instances were actually patched for Oh My God, which is no surprise given the auto-updates, which means that auto-updates are an effective way of addressing vulnerabilities in cloud middleware agents. And to summarize Microsoft's approach to cloud middleware vulnerabilities, they eventually decided that customers will be responsible for maintaining all the software running in their assets, including cloud middleware vulnerabilities. One of the reasons for this is that simply customers do not really want the cloud providers to interfere with their machines. They would much rather updating those agents independently in their own schedules and not causing unnecessary downtime. Therefore, customers should keep an eye for vulnerabilities released in the Patch Tuesdays and to make sure they're not impacted and patch whenever needed. There are no automatic updates, even though they might be planned in the future. But in some rare cases, Microsoft will auto-update the agents, such as the Oh My God case. Let's move on. As Nir said earlier, most cloud providers do use cloud middleware agents in order to enable certain features. And now we're going to talk about a simple cloud middleware agent affecting AWS environments called SSM. SSM is one of the most prevalent cloud middleware software across all cloud providers. It usually comes pre-installed in the AMIs provided by Amazon, and it is essentially the agent that is used in the AWS Systems Manager service, which is simply a collection of capabilities that help you manage applications and infrastructure in AWS environments. Security-wise, it runs at high privileges, just like OMI. It is open source, which, as Nir said, is a very good thing, but you can enable for it automatic updates, which means you will always be at the latest version possible. However, this feature is disabled by default, and you would have to manually enable it. And if you look at the SSM version distribution, as you can see, there is a pretty wide range of versions that we found in the environments we checked. And if you would look closely at this blue section of the pie chart, you would see that only 23% are at the latest version possible, meaning that the maximum amount of SSM instances that have these automatic updates enabled is 23%. Most customers are not really interested in those automatic updates. SSM had a recent vulnerabilities that was announced a few months ago. This is a local privilege escalation vulnerability. I'm not going to talk about it in details, but I am going to show you that only 27% of the agents were actually patched for the vulnerability, meaning that customers both do not opt in for automatic updates by Amazon and do not patch their own agents, which is quite surprising. And to summarize AWS's approach based on only our observations, customers are responsible to maintain the software in their assets, including the cloud middleware agents. However, you can enable automatic updates for them, although they are disabled by default. And as we said earlier, customers do not really opt in for them. They would rather update their agents alone. But they do issue CVEs for cloud middleware vulnerabilities, meaning they're easier to track in their environments. Let's move on to another cloud middleware agent called osconfig, which can be found in GCP environments. It usually comes pre-built in the GCP virtual machine images, and it's essentially a part of the GCP VM Manager service, which helps you with patch management, inventory management, and configuration management. Security-wise, it's also running at high privileges, just like the previous agents. It is open source. As far as we know, there is no option for automatic updates. As you can see, the version distribution in this agent is also pretty wide, and only 4% of the agents are the latest version. I will say that there is no really a good reason to update this agent because there has been no recent vulnerabilities in it. However, we did manage to find one vulnerability in it. It was reported to Google and did not get assigned a CVE. We're not really sure why. I also will say that there were vulnerabilities in the Google osconfig agent, not the Google osconfig agent, in other cloud middleware agents that did get assigned the CVE, so I'm not sure why this one didn't. And I will say that we had a pretty hard time finding vulnerabilities that affected these agents by Google, meaning that their overall security posture is pretty good. And to summarize their approach, the customers are responsible to maintain the cloud middleware agents. There are no automatic updates for them, and they do issue sometimes CVEs for cloud middleware vulnerabilities. And to summarize what we've learned, there is still no standard in the world of cloud middleware vulnerabilities of how cloud vendors address these vulnerabilities. Each vendor has a different approach. They do what they see fit. Some issue CVEs, some don't. Some opt in for automatic updates. Some don't even have this option, etc. However, most customers do not want the cloud vendors to interfere with their machines. They would rather update their own infrastructure in their own environment. In order for them to do that, they must be very transparent. The cloud vendors must be very transparent about the agents they install, which means that they should acknowledge the customers that whenever they enable a certain feature or deploy a new virtual machine, that they will have this agent in their environment. They should issue CVEs for the vulnerabilities that may arise in those agents and provide detailed mitigation guidelines for the vulnerabilities. And eventually, they must alert the affected customers. They must send a notification to the customer to make sure that they know they are at risk and what exactly they should do to fix this issue. From the customer side, as we said earlier, most cloud providers give you the responsibility for the agents, meaning that they should threat model the agents that they have in their environment and decide whether or not they want to enable a certain feature which installs a certain agent. Whenever they install this agent, they must track their existence in their environment and make sure that they know whenever a new vulnerability arises in those agents and to patch them whenever needed. To address the issue immediately, we decided to create a community-driven dataset that contains all of those secret agents that we managed to map across different cloud providers, which can be a pretty hard thing to do. We encourage you to take an interest, to read about the different agents, to add any more information that you see fit. And with that said, I think it would be a really good time for questions.
Thanks a lot. So just start with one question. So this reminds me, and I guess maybe I'll date myself here, although I'm not quite this old, of whenever I'd get, say, a new Linux bare metal instance that I would build, the first thing I would do is turn off send mail, because send mail is impossible to configure, probably vulnerable, and would turn you into an open relay. It feels like some of what you're talking about here is similar to, hey, this is a send mail that comes on your instance. Like, how do you think about or contrast this cloud middleware versus like a send mail type situation?
So yeah, before we discovered the term cloud middleware, internally we refer to it as like cloud OEM software. So it is very similar to things like SendMail, and but unlike SendMail, cloud middleware software does like have security consequences, because it's SendMail usually doesn't run at high privileges or anything like it. So. That's pretty much it. Like in Linux, a lot of times you get a lot of software in your Linux Linux operating system, but it's not running. The binary is only like the only thing there. But in this case, they're running at root privileges and so on.
Thank you.
Thank you. In your experience, how good did you find things like traditional vulnerability scanners and application inventory software at being able to identify the presence of this software, as well as track and compare its vulnerabilities?
Different like products have different approaches to how they detect vulnerabilities or hosted technologies in their environments. It really depends on the agent, how well they will be able to identify the vulnerabilities and the technologies installed. I will say that some agents have a CP and some don't, which makes it easier or harder to detect in environments.
Question coming from our Slack. This is specific for GCP OS login. How can customers update it? Do you need to uninstall the old and install the newest? And then start thinking more broadly of, are there challenges customers face with updating, like for example, with the SSM agent, that may be how they actually go about doing updates and might run into a chicken and egg problem?
So regarding the OS login agent, the way to update it is to, like according to Google's own mitigation like guidelines, it's to update the operating system image itself. And when it comes to SSM agents, as Rotem mentioned in the presentation, you can actually enable auto updates, and like AWS will take over that for you.
Thank you. And then you also kind of laid out some of what you think are the right principles for how to handle the cloud middleware, who should do what. And you also talked about sort of the individual big three clouds and how they do it. And can you sort of talk about like who you think is doing it best and who you think sort of needs to go the furthest based on your opinions?
Tough question. I don't think like there is like, they're all taking different approaches, and they're all like different on how transparent they are on it, or which one of them are like offering automatic updates and which don't. We personally think that we don't think that automatic updates are the solution. We basically think that transparency is the solution. If like when I enable the specific feature on the user's portal, and there will be a prompt that says, be aware that this agent is going to be installed, and then like it can be going through some thorough security review by the company's security team. I personally think that will be the best solution, and all cloud providers are doing it on like varying.
I guess one final question is, you're talking about sort of Microsoft's response to Oh My God, and kind of the first one, which was a bit lacking, and the second one that drew praise from you. And I was reminded to an earlier talk in this room, Kat Traxler was talking about how she got what she thought was a lackluster response from AWS Security reporting the issue she had, and was talking about how she thinks that she could have done a better job of getting a better response from them. And so, do you have reflections on how you could have handled the initial interaction with Microsoft better, and in general suggestions for other people in reporting these kinds of issues to make sure they get a good quality response to security issues that they find?
You can answer it.
Okay. So in retrospect, you can also like always look for things that you could have done differently. So
Hindsight is 20/20.
yeah, exactly. So like in this case, we did ask Microsoft on how they're going to handle the patching. Are they going to do auto updates? Are they going to like send customers an email notification? But we didn't really like get a response. And like in retrospect, maybe we should like press harder or something, because like we always like in the communication we ask a lot of questions, and some are getting answered and some not. But in these kind of critical questions, we might have needed to ask a bit more.
All right. Well, thank you very much. Let's give Nir and Rotem a final round of applause.